Bismillahirrahmanirrahim. Dear student, my name is Vairavan and this is our fourth lecture of artificial intelligence. So, the topic that we have to discuss today, it is very important topic that what is agent and what are different types of agents. So, agent is the fundamental component of an AI system. What is AI agent? An agent perceives its environment through sensors and act on the environment through actuators. So this is agent that the agent will receive any kind of information through its sensors, and then on the basis of this information sensing from the different environment, the agent will act upon with the help of actuators. The best example of agent is that our eyes are looking anything or any environment, and on the basis of those looking or those sensing, our hand moves. So this is one example of agent. In artificial intelligence, there is a smoke sensor that is in some room, and that smoke sensor sense a smoke or any kind of smoke in the room. So the sensor is sensing this environment, and then that sensor will have actuator. The actuator is like alarm. Whenever that sensor will sense any smoke in the room, the alarm will will speak out that there is some smoke inside the room. So this is the example of agent. So in this slide, you can see that there are different types of agents. The first type of agent is simple reflex agents. The second type of agent is reflex agent with state. The third type is goal based agents, and the fourth type is utility based agent, and the last one is learning agent. So these are the different types of agents that are working or that will work in the artificial intelligence, or what they do increase in the generality and ability to handle complex environment. This is the main purpose of agent. So here we have simple reflex agent. Here you can see a picture. We will start from the simple if then rule. Use simple if then rules can be short sighted. In simple reflex agent, reflex means you have to move or you have to act on the basis of any environment. Reflex means that anything that is coming to, like you are playing a cricket match, you have bat in hand, and when you look at the ball, then you move your bat. So these are your reflexes. The more your reflexes will be strong, the more your reflexes will be fast, the more you will uh, tackle the ball accordingly. So in simple reflex agent, only if then rule you have learned. If then in C or C++, that what is simple if then rule, if then else, if then else. So uh, start look at this example. Here we have environment. Consider is it is an environment, and this is the agent body. So what is inside the body of the agent? The inside the body of the agent, what is the world is like now? So this is the sensor. This sensor could be smoke sensor, this could be light sensor, this could be noise sensor. So this sensor will sense from the environment. And what is the sensor is saying? The sensor is saying what is the world is like now. Okay, after sensing the environment, what is the next process? What action I should do now? So the sensor has sensed the environment, and now it is questioning, or it is in the decision process, or it is thinking that what action I should do now. For suppose that this sensor is smoke sensor, and it has sensed the smoke from the environment. So this sensor is now thinking about what to do. So what you think what this will do? This is sensor, and it has sensed the smoke from the environment. This is the room. What action it will take if it has senses any smoke? It will first it will check the condition, and it will have action rules. So for the smoke sensor, the action rules will be uh, switch on the alarm or switch off the alarm. So if this sensor has sensed the smoke from the environment, so here the action would be switch on the alarm. So here the next step is actuator or effectors. The effector will be here. If as I suppose that this is an example of smoke sensor, here will be a speaker that will speak out, or it will ring out any alarm. So the sensor is sensing from the environment, it will process it, and then it will have some action rules, and on the basis of action rule, this will actually work for the environment. So this is simple reflex agent. Like it has sensed anything from the environment, and it will simply work accordingly on the basis of action rule. So this is very simple. Can be short sighted. This is the one of the basic and fundamental agent, that is simple reflex. Here is an example of simple reflex agent. Vacuum agent. So what is vacuum agent? The machine that you use in your homes for cleaning the carpet, that is known as vacuum agent. It has some kind of sucker inside here, and it will suck all the uh, dirty materials by this actuator. So what is the performance of this vacuum agent? 1 point for each square cleaned in time. 1 point for each square. Definitely there will be some kind of area, and the vacuum agent will have a time, so it will act upon on the basis of time. Clean squares per time step. if we have 1 square feet, so how much time this actuator takes to clean this particular area? Environment, vacuum, dirt, this could be multiple area defined by a square region. Definitely there would not be very small area, there could be a very large area. So what are the actions that this vacuum agent could take? One is it can move left, it can move right, it can suck, and it could be idle if there is no particle in front of the actuator. So the actuator or this vacuum cleaner will be in idle state. Sensors, location and content. A for dirty. Rational is not omniscient. Environment may be partially observable. Yes, this, as we have discussed in our last lecture, that this environment would be partially observable. This is not fully observable. Rational is not clairvoyant. Environment may be statistic. So here is reflex vacuum agent. If status is equal to dirty, then return suck. Yes. If the actuator is facing or it has sense any type of dirt, that it will definitely suck. Else, if location is equal to A, then return right. If location is equal to B, then then right, left. Here is another agent, that is reflex agent with state. So this is, as you can see in the picture, this is little bit uh, complex sensor agent. So what it do, store previously observed information. Yes, this is one basic uh, um, property of this reflex agent, that it stored previously observed information, can reason about unobserved aspects of current state, can reason about unobserved aspects of current state. So this is a bit complex type of agent. Here is the environment. As we have discussed in our previous agent type, what the world is like now. This is the sensor. This will sense from the environment, and definitely it would have state, how the world evolves, what my actions do. So this these are the different states, extra state, that was not in the simple agent vacuum. This was a simple reflex agent. We do not have these types of different, I must say, different properties or different actions. So on the basis of these different equations or different statement, what action I should do now? Definitely a condition, and there would be action rules. And on the basis of these action rules, one thing both of these agents have common, that there is a condition and action rule. Here you can see condition and action rule. This has sensor, and this also has sensor. This has simple reflex agent has effectors, and this agent also has effector. So the one thing that is extra between reflex agent with state are these three. So these are the different reflex agent with state, percept. There would be state, there will be rule, there will be action and action return. State would be what is the sensor is perceiving from the environment. Rule would be what are the different rules that the actual robot can do on the basis of sensing and action. This is rule action. These are the different actions that this can do, and what is the actual return out. So this is a bit complex agent, that is reflex agent. Reflex vacuum agent, if status is equal to dirty then suck, yes. If this vacuum cleaner is facing any type of dirt, then this will definitely suck. And if have not visited other square in is greater than 3 times unit, go there. Okay, this dirt has this vacuum reflex vacuum cleaner have the memory inside, that this condition is saying that if you are given a particular area, as I have a pencil here, I can draw here. If this is a particular area and this is also a particular area, this example is saying that if we have these are the dust particles. Let me check. These are the dust particle. Here is another dust particle. Here is another particle, and here is another particle. Look, there are two dirt particles in this environment and that environment. Actually, okay. So, if my actuator or my vacuum cleaner has visited this place only once, and it has start going to this place, so what my reflex vacuum agent will do, it will check this condition and will say that go to box number 2. This is suppose box number 1. Go to box number 2 and vacuum or clean this particular square twice, as dirt then suck if have not visited other square in greater than 3. Like, the vacuum cleaner had to clean this box number 2 for 3 times, sorry. And if it has only clean for 1, so this vacuum reflex vacuum cleaner uh, send uh, send the agent to clean this place as well. So this is reflex vacuum agent, that it has a memory of recent activities. Okay, dear students, we have the next agent is goal based agent. So in goal based agent, we will first compare this diagram with the previous diagram. So look at this diagram carefully and look this diagram carefully. This is reflex agent. And look at this diagram carefully. This is simple reflex agent. So this is simple reflex agent, this is reflex agent, this has this much extra, and this is goal based agent. So in goal based agent there is environment, there is sensor, and goal reflects desires of agents. Goal reflects desires of agent. Like, desires of agent means what this agent wants to, or what is the desire of this agent, that what he wants to do. May project actions to see if consistent with goals. Takes time, world may change during reasoning. There is a possibility that if a sensor is sensing the smoke and suddenly the smoke stops, so the environment has changed. So in this goal-based agent, we have what is the world is looks now, what it will be like if I do action. So here is another addition of the state, that what it will be like if I do action A. So there could be possibilities that the agent could do. What actions I should do now? So these are the, and this is the goal. In the previous example, I we have seen that the condition and action rules are here, and but here the agent is working on the basis of goal. So this agent will work. What is the actual goal is utility based agent. This is another type of agent. So this is in this you can see there are more addition. These both are same. How happy I will be in such a state. Okay. Evaluation function to measure utility. Utility means satisfaction level, useful for evaluating competing goals. Here we have environment, we are sensing. Here we actually we have to tell about the satisfaction level of the system, or could be any customer. So here is the state. This state is demonstrating that how happy I will be in such a state. If here we have some state and we have given this state to any person, so this state will work according to the utility. And what action I should do now? As you can see, these action would be according to the utility. Here is another type of learning agent, another type of agent. This is learning agent actually. Learning agent means it will face some problem, or it will observe anything, and then on the basis of those observance or those observations, sorry, this agent will actually work on. This is the environment, and this is the sensor. Here is critics, performance standard. This is performance standards. Here is feedback, performance element, learning element, problem generator, and this is actually actuator. This is sensing. It has sent the performance standard. We have received feedback, and then we move on to learning element. So sensor standards, it will receive feedback, and feedback is going to learning element. And here this is vice versa, that the changes knowledge, this is sending to changes, and this is actually moving to knowledge. This is sending changes, and this is sending back knowledge. This is actually the problem generator. That the learning, what is the learning goals? So problem generator is here, and this is also participating in the performance element. So basically sensor is giving input to this state. Learning element is also, learning element means that any type of system that is evolving itself, or that is increasing its knowledge. And this is problem generator, this is learning goal, and this is actually these three are basically working on this particular I must say element, or this part of the agent. So at the end, if all these have given the elements, so this performant element will actually actuate on the basis of three things, three feedbacks. So and finally the actuator will give answer to the environment. So, dear students, we have learned three types of agent here, five types of agent. This is simple reflex, this is reflex agent with state, this is goal based agent, this is utility based agent, and this is learning agent. So, Pathfinder medical diagnosis system, if we have four types of four headings like performance, correct, hemopathological diagnosis, like this is homeopathic like diagnosis, environment, automate human diagnosis, particular observable, deterministic, episodic, static, continuous, single agent. This would be the environment. Actuator output diagnosis and further test suggestions, like on the basis of the performance diagnosis uh, observed from this environment, the actuator will diagnose or it will suggest further outputs. Sensor input symptoms and test result. The sensor is actually when we take any biopsy or you take any test sample from the any environment or any that could be any person blood. So uh, inputs, symptoms, and test results. Reasoning, Bayesian network is one of the basic network machine learning algorithm in which it gives reasoning for what to do in the particular environment or in particular problem. Dear student, this is the part of your I must say your course outline. These all are the expert systems. So what are the expert system? Expert system actually works by their own. They have their own memory. They have their processing. Expert system means like the best example of the expert system is your ATM machine. Here are shuttle packing system, military planning, intelligent vehicle, highway negotiation, credit card transaction monitoring. These all are the systems that work automatically. Billiard robot, juggling robot, credit card fraud detection, Mars rover, sky survey, galaxy data analysis. So these are the different types of expert systems that are working in the environment very effectively nowadays. Example of a system, yes, knowledge representation. This is search, problem solving, what is planning, what is machine learning, natural language processing, uncertainty reasoning, computer vision, and robotics. These are different types of artificial intelligence systems. Example, knowledge representation, that like here you can see something written on the in front of these guys. So how the system is representing any knowledge, how the system will search, how the system will resolve problem, how the system will plan, what is machine learning, giving data to computer and then train some any type of model. This is known as machine learning. Natural language processing, like all languages that are and that are I must say that are the human languages are called natural language. Uncertainty reasoning, in which we have the probability that whether this is positive or negative. So this is uncertainty reasoning. The next is computer vision, like anything that is on the basis of uh, the according to the camera, that what the camera is looking, this is computer vision. And robotics, all the robots of artificial intelligence is under the robotics. Robotic mean a programmable machine that works automatically. This is known as robotics, and this is one of the basic field of artificial intelligence. So, dear students, this is all about our uh, fourth lecture. Inshallah, we will discuss many other topics in our coming up lectures. You are advised to please search out all these topics from the Google as well, so that you can understand more effectively. And if you do have any kind of problem or any type of question, you can simply email me or you can WhatsApp me. I will definitely try to reply you. So, till then, next lecture, see you in next lecture. Allah Hafiz.